Welcome, everyone, to the Foundry by Forge College. Today, as part of our Applied Solidity development track, we're jumping into a crucial part of the Patterns for Enhanced Usability module. Specifically, we're tackling a topic that honestly humbles even the most brilliant developers out there, and that is feedback and usability testing for smart wallets. We're going to explore exactly why your mathematically flawless, perfectly coded smart wallet absolutely needs a serious reality check. But hey, don't worry, we aren't just going to tell you to make it pop or make it pretty. No, we're going to treat usability as a rigorous and surprisingly fun engineering discipline. Okay, so let's dive right into this. If you recall our previous lesson on configuring mainnet-like environments, we spent a ton of time perfecting the backend. But today, we're contrasting that super predictable mainnet environment with the absolute unpredictable chaos of the human environment. Because let's be real, here's the undeniable truth. Code doesn't get confused, but humans staring at a screen definitely do. You can have literally the most secure contract on the blockchain, but if a user accidentally hands their life savings over to a phishing scam just because a button was confusing, well, your security model is pretty much toast. To fix this, we're going to treat usability as a rigid engineering blueprint broken down into these 5 mechanical steps. First, the usability gap. Second, forming testable hypotheses. Third, building minimal prototypes. Fourth, running moderated sessions. And fifth, synthesizing actionable findings. Let's get to it. Starting with Section 1, the usability gap, or where code meets confusion. You see, this system failure doesn't happen on the blockchain. It happens right there on the screen. There's a quote that brilliantly illustrates our core problem. A wallet pattern can be secure on paper, yet confusing in practice. Think about it. You know exactly how a multisig threshold 2 protocol works, right? It's like requiring 2 out of 3 keys to open a vault. But to your everyday user, threshold 2 sounds like a terrible sci-fi movie sequel. If they don't instantly understand the consequences of their click, you get cognitive overload, massive frustration, and ultimately lost funds. Technical correctness is absolutely crucial, but it's just not sufficient on its own. Moving right along to Section 2, forming testable hypotheses, where we engineer the user experience. To solve this usability gap, we need a feedback loop. We have to fundamentally shift our whole mindset from subjective feelings to testable hypotheses. Basically, we're taking vague design assumptions like, well, I really hope they understand this progressive consent flow, and transforming them into concrete, measurable interface metrics. We're turning I hope they get it into let's measure exactly if, how, and when they get it. So the crucial takeaway here is that we are going to extract 4 exact metrics from our users. We are literally stress testing human interaction the exact same way we monitor server loads. First up, task success. Just a simple pass or fail. Did they do it correctly without asking for help? Second, time on task. How many actual seconds elapsed from start to finish? Third, errors. What specific misinterpretations happened along the way? And finally, confidence. A self-reported rating on a scale of 1 to 6. Just ask them, hey, how sure are you about what you just did? All right, Section 3, building minimal prototypes. Remember, wireframes, not masterpieces. Now, to gather those metrics, we obviously need a testing vehicle. But hear me loud and clear on this, you absolutely do not need to build a polished mainnet-connected app. No way. You only need a minimal modal prototype. We're talking just basic web elements here. Simple text and buttons just to check user comprehension. No real cryptographic keys, no wallets actually connected. Just enough to present a decision screen. Show them the signer list, the threshold indicator, a super clear description of the action, a risk signal, and confirm or cancel controls. This completely isolates the interface from the complex mechanics, making sure your findings are actually about UI clarity and not blockchain log. Okay, Section 4, running moderated sessions. Welcome to the 5-user stress test. This rigorous, empirical approach to user testing is emphasized all across Forge College programs, mainly because guessing just doesn't scale. Now, you might think you need a massive 50-person focus group to get statistically significant data, but actually, you really don't. 5 moderated 10 to 15-minute sessions are exactly what you need to gather a highly actionable signal. I promise you, by the 5th user, you will see the exact same pain points repeating over and over. Anything beyond 5 in this initial stage is honestly just redundant. So here is your strict sequence flow for each of those 5 sessions. You start with an intro to explain that, hey, you are testing the interface, not their intelligence. Then you move to task A, which might be something like confirming a transaction. Follow that up immediately with a post-task probe to gauge their confidence. Then run task B, maybe a social recovery flow, and finally finish with a wrap-up. The golden rule here? During the tasks, you must act like a scientist. Observe silently. Do not guide their mouse. Do not give them hints. Just watch. Now, pay attention, because this right here is your magic prompt for task A. Walk me through what you understand, then choose confirm or cancel. By forcing the user to explain their thought process out loud before they click absolutely anything, you get this amazing real-time window into their cognitive process. You find out exactly where the interface is lying to them or tripping them up. What's really fascinating about this dual measurement approach is logging task success against time on task. A user might technically succeed in confirming the transaction, giving you a positive pass result, right? But if your console logs show they stared at the screen in pure agony for 45 seconds before clicking, that massive time on task reveals severe UI friction. So a technical success can absolutely still be a usability failure. And finally, Section 5, synthesizing actionable findings, taking it from data to blueprint. So now we take all our raw observation notes, the timestamps, the error logs, and the confidence scores, and we build the ultimate engineering artifact. This comparison table is your bridge between observation and action. You are mapping user confusion directly to prioritize UI fixes. We don't just wave our hands and say, oh, users were confused. No, we create a ledger. Finding ID, the measurable evidence, the observed pain point, the specific recommended interface change, and a priority level. Let's see how this actually builds into a real example. Imagine a row labeled F1. The evidence shows 3 out of 5 participants misread the threshold, taking an average of 42 seconds. The observed pain point? An ambiguous label. So the recommended change is highly specific. Change the text to required signers 2 of 3 and add a helpful tooltip. Because it caused a 60% failure rate and a really high time on task, the priority is set to high. This isn't guesswork, folks. It's data-driven design. To make sure your tests are actually useful, your synthesis must hit these exact checklist requirements before you even think about writing design tickets for your team. You need a minimum of 3 measurable findings. Each finding needs at least 2 independent observations to prove it's an actual pattern, not just a fluke. You need exactly 1 specific implementable UI change per finding, and your prioritization must be totally defensible based on the metrics you gathered. All right, conclusion, proving it in practice. Let's wrap this up. Building smart wallet patterns goes way, way beyond just writing clever Solidity code. It requires actively testing human comprehension. Your wallet might be secure on paper, but are you ready to prove it in practice? Now it is time for you to build your minimal prototype, run your 5 sessions, and find out exactly what happens when your code meets the user. To explore more Web3 engineering frameworks and keep mastering your craft, head over to forge.college. Thanks so much for joining me on this explainer, and keep building.